Welcome to today's class. It is set number 5, the solution of various entrance exam on haloalkane and haloarene, and the topic is mainly on reaction and reaction mechanism. Please minutely follow the class. A lots of questions, 20 questions will going to be answered with details. So first of all, you see the first question is this. Cyclobromine plus magnesium diether A on hydrolysis give B. It was asked in NEET 2021. The solution is very simple and you just see the way. So you see the writing of the Gigner reagent is Mg is plus and this is minus. So plus part will go to here and minus part will go to where. This is the trick, and just to follow the trick you will get the answer. This is the answer. Very simple. A lots of options are given. I have avoided writing the options due to time. This is the first question. The question is a bit typical and hard. IIT screening. The question was asked. Just it is the reaction is given in this way. So the clue is here, sodium and ether. When sodium and ether, this is Wood's reaction, but here 2 equivalent of sodium is used. So first of all, what's happened? Bromine and chlorine. Out of this, bromine is good leaving group than chlorine. The leaving group order is am I right? So bromine will first leave and it will give you this. Will be like this. This is the answer. The question was asked in IIT screening. It is not hard, simple. Important. C2H5 Cl AgCl. This question is very often asked in your class and board, All India board or state board. The question is very often asked. So this is generally done in alcohol medium, and AgCl it is not given, but you should understand the question was asked in EMA CET exam, and here AgCl. Why? What AgCl? AgCl is a covalent one. So due to this covalent nature, it doesn't break up into ion Ag plus and Cl. It does not break up in this way. So since it doesn't break up as Ag plus and Cl negative, that's why it has only lone pair left here is upon this one. Am I right? So it reacts, attack here, and chlorine withdraws. You will get C6H5 NC. N lone pair of N attacks. Am I right? So the bond will be with N, not with C. So isocyanide. So question is asked, the bond between ethyl and CN group is through C through N. Option was this. Answer is option. This also option is correct, where ethyl group is linked to N of CN, isocyanide. But had it been KCN, if it is KCN, so if it is KCN, then KCN would have broken in this way. So there are 2 possibilities, one attacking through C, other attacking through N. But since CC bond, this is carbon part of ethyl and this is chloride, and had it been KCl, it is ionic, K plus Cn. So there is 2 options of attacking either through C or through N. Since carbon, if you attack through C, so CC bond is more stable than NC bond. So attacking through CC will preferable. So this will attack in this way through C of Cn and it will go in this way, your answer would have been Cn. So when it is KCl, it would have been cyanide group, and when it is AgCN, so it is covalent, it would be through N, because there is no option left to get free of plus and Cn negative. So there is lone pair attacks through nitrogen, so NC bond appears. This is very important question, very often asked. Is this the question? When this is react with magnesium, so very often when you get the magnesium, you will get Grignard-Diesel. So first part is not required to explain. This is this. Now you are asked, this is first, this is second, and this is third. Now you will be concerned with the second part, carbon dioxide. It is a bit hard, and you just follow this one. What is carbon dioxide? This is first, this is second, and this is third step. In the second step, you are reacting with carbon dioxide. So bond is withdrawn in this way due to electronegativity. This is negative. Am I right? And style of writing Grignard reagent is metal is plus and non-metal carbon is always minus. So here, if this is plus, if this is minus, this part is plus. So the plus part will get attached with this one, and this will get attached with this one. So what we get here is so along with minus part, it is minus actually OMgBr, and this part is like this. O is attached with carbon of this. So in this way we have attached. Now what is hydrolysis? Hydrolysis means H3O positive means acid hydrolysis. So water will breaks up in this way. So the bond will break. This is negative. Am I right? There will be H positive. Am I right? And this will be here. So you are getting this part. So what you get here is, so you apply the technique, otherwise you will not get the correct answer. 4, CH3COCl. Question number 4, you go through question number 6. You minutely follow. This is acid chloride. Acid chloride. I am writing the answer and I will show the how you will get the answer. Answer will be only this part will become CHO. This is the technique. And if you ask me how, then I will tell you. This is the way of writing. You write the reagent in this way, 2 hydrogens are there. It is a reduction. So just in place of chlorine, you put H, CH3, COOH. Actually, whenever you get acid chloride and you get the reagent H2 palladium over barium sulfate, you recall the reaction Russell-Mund. Russell-Mund reduction, and this is a very famous name reaction. Sometimes reagent is given, sometimes answer is given, you may be asked to write the name reaction. So it is Russell-Mund reductions where acid chloride, only chlorine is replaced by 1 hydrogen, not mechanism, the technique, you will get the answer. Sometimes you will be made confused in the examination. They will give you in this way, palladium over barium sulfate. You may be asked to do this. So again, you this acid chloride in place of chlorine, you just put the technique, you follow the technique, you just put H, means CHO, benzaldehyde. Am I right? So these are the three. What reagent converts what, you follow this one. What may be the structure, may be big and very complicated, just you go to the functional part and try to solve this one. Next one again is question number 5. Question number 5 is CH3Br, and this question seems to be very simple, but many of you cannot answer this one. I'm talking about something when you will get zinc or copper or silver in fine powder state and it is heated, it follows almost Wurtz reaction. There is a bit difference, but I will show you. It follows Wurtz reaction. You may not follow, but that's why very often this question is again PMT exam it is asked. Now what you do here is CH3 Br zinc Br CH3 and you give heat, you get the answer in this way. Only difference is that when it was sodium, you had written twice sodium, but here you need to write 2 on the zinc. So you are getting CH3 same as Wurtz reaction, but here answer ZnBr2. No need to do anything. It will be in this way. So you may not assume the option alkane, but minutely follow when zinc or copper or silver in powder state and it is heated, that alkyl halide gives you reaction. The type is almost the same as Wurtz reaction. X plus NH2. Question was asked in DCE and exam, and CH3 CH2 NH2. Answer: when reduction, there one carbon will increase. You were asked to find out X. Now what is X? Simply I will tell you it is chloride, alkyl halide. Answer will be CH3Cl. Now how? I am showing you. Say you assume CH3 Cl plus KCl. No need to explain, all of you know. It is replaced CH3 Cn. Again on reduction, twice hydrogen and nickel, it is reduction. What's happened here? Whenever there is a question of reduction, one carbon is increased, length is increased. Am I right? So minutely you keep one clue. When CH3 on reduction, the clue point is it becomes CH3NH2. This is the clue point. Cn on reduction give you CH2NH2. I mean, this is the clue, this is the rule, this is the fact, this is the point. You should keep it in your mind. If you ask me how, then I will show you from here. CH3 C triple bond N, and you are adding hydrogen twice, am I right? So 4 hydrogen atom will add 1 hydrogen here, other hydrogen here, another hydrogen here. This is clue, this is the trick, not mechanism, and another hydrogen here. So just you arrange the bond. There should not be triple bond to make it 3 bond, so you just make it this. So what you are getting is CH3CH2 NHs. So if you are happy with this one, you follow this one, and if you are not happy, you need to know trick. Then Cn always becomes CH2NH2. On reduction, one carbon is increased. Am I right? So this is about question number 7. An alkyl halide X reacts with sodium to form 4,5-diethyl octane. And the clue point here is it is made to react with sodium. So when a reaction is done with sodium, basically from alkyl halide with sodium, no ether is mentioned, but instantly you think of Wurtz reaction. So it is nothing but Wurtz reaction. So you have got 4,5-diethyl octane, very long answer. So what is that X? From which alkyl halide you have got this? You will be confused. So please try to write 4,5-diethyl octane. What is 4,5-diethyl octane? Again it will be tough. So it is, if it is octane, so very often Wurtz reaction, if it is the starting alkyl halide is with 4 atom, it will be 8 atom, twice of this. If it is methane, methyl chloride, it will be ethane. CH3Cl, again other side CH3Cl, 2 CH3 combines, means single gives you 2 carbon, alkyl halide with 2 carbon will give you alkane of 4 carbon. So it becomes double, even numbers. Am I right? So from octane, you have got the idea. Your starting material was with 4 carbon. So let us technically write CH3, CH2, CH2, and you write here C 1, 2, 3, 4. Yeah, 4, 5. You forget about this. You are getting octane. Octane should come from butane. So 1, 2, 3. But the point is, ethyl is there. Di, forget about di. Ethyl is there. So in one butane, there should be ethyl, and ethyl should be at the end, because if the alkyl halide is at the end, very often the reaction combines 2 alkyl halide with 2 sodium and it leaves out. So you give it here ethyl, am I right? So you have written butane to get its octane, make it double. So we are, for ethyl we have written here ethyl, am I right? So there should be alkyl halide, am I right? So it is alkyl halide. So any halide you give it bromine, or X, you give it X, anything X. So 1 hydrogen is left, am I right? 2 values. So very minutely follow this one. We have got one part. Let us check whether it will give this 4,5 diethyl. So another will be of same, that will be reverse of this. You make it reverse. This is first, and CH2H5 in the second place. This is in the third place. This is in the last place. And when you give sodium twice, then these two combines. So you join up these two. Are you not getting 1, 2, 3, 4, 5, 6, 7, 8? And 1, 2, 3, 4 means 4 ethyl, and 5, 4, 5 diethyl octane. Means your starting material is this. In the option, it is given X. So your option, a lots of things are given. You choose this one. This is a bit hard, but very simple. Needs technique to get the answer. CH3. This question was asked AI triply, and in the 2022 probably a question of the same type, that was alcohol, was asked, and this question involves rearrangement, and maximum of you without rearrangement gave the answer. You have got -1. Mind that if there is a rearrangement, and this is a very important type of reaction. Now what's happened, when this compound is made to react with methoxide and in methanol, what will be your answer? So first of all, you remove this one to get carbocation. So what you get here is this is 1 degree carbocation, am I right? But soon you get carbocation, because it is leaving groups and there are some methyl groups. There is possibility of getting carbocation. Sometimes it does not give it because it gives SN2 mechanism, but it will give, because you will understand why it will give. Because the carbocation forms 1 will no longer will live in carbocation 1, it will transform to carbocation 3. So more stable carbocation will be attacked by the nucleophile. This will be SN1. SN1 mechanism what? More stable carbocation is attacked by nucleophile. So it is least stable. So what's happened here? Hydride will shift. So what you are getting here is CH3, CH3. This is called 1,2 hydride shift. Hydride will shift. Now you are getting this is as what? 3 degree carbocation. But many of you may tell that there may be the chances of shift of methyl group. There is 3 types of shift. One is methyl group, other is hydride group, other is phenyl group. There may be shift, but the chances of movement, this is the first, then methyl shift, then phenyl shift. Am I right? So there is chances of this group shift over this one, but when you want to shift this is over this one, again there is CH, you will get 2 degree carbocation. CH plus means 2 degree carbocation, but Here 3 carbocation is the most stable. So in this place H will move, hydride will move, not with methyl. That's why according to this hydride will move first, then methyl, then phenyl. So we move hydride first. Am I right? Now you made the attack of nucleophile. So your nucleophile is what? CH3 O negative. It will attack on carbocation. So when nucleophile attacks, it will get attached. So your answer is CH3, C, CH3, CH3, or CH3. A lot of options are there. You please don't attach OCH3 here. Instantly don't make attack of this one. Your answer will be wrong. You will get -1. So minutely follow the shift if there is any chances of shift of carbocation in the reaction. It is very important to know what is the reaction that will follow through SN1 in the question it is given, and the question was IIT JEE. Am I right? So phenyl magnesium bromide. So what is phenyl magnesium bromide? This is phenyl magnesium bromide, and it is made to react with what? Butanol, third butanol, CH3, CCH3. One thing you write in this way for your understanding. It is 3 degree alcohol, am I right? 3-methyl group is the third butyl alcohol. So what is the way of writing Grignard reagent? This is plus and this carbon is non-metal is minus. Am I right? So if you assume it plus and this will be minus, very simple question. Minus will come get attached with this one and plus will get attached with this one. Very simple. Maybe IIT answer is very simple. And earlier question was 4,5 diethyl octane was asked in row K. Humanity follow. So your answer is simple benzene, nothing else. Am I right? So very important and beautiful answer. This question was asked in CET Kerala. This compound when made to react with HBr you get A, and when same compound made to react with HBr with H nu you get B. What is A and B? In the option I have not given, I will show you the answer. This is very simple because you just follow Markovnikov rule that carbon having less hydrogen and it is having more hydrogen. So this is unsymmetric addendum. Negative part will get attached to the carbon having less hydrogen. So your A will be very simple. No thinking is needed. Your A will be here bromine and hydrogen will be this, and no double bond will be there, hydrogen will be added. So we have got this one. Now come to this one. When you will talk about HBr with H nu, so there is free radical. There is free radical mechanism. So here you are getting from HBr, when it is H nu, ultraviolet light is given, then HBr becomes free radical, H dot and Br dot. So you are getting Br dot. So when splits up into two radical H dot and Br dot, so you do one thing, double bond you write in this way. Am I right? So this odd electron and that electron will make a bond. This will make a bond. So what you are getting here is very technical question and very beautiful answer. You have get this, and this two has make a bond, so you give the bond in this way. Am I right? Now when this odd electron makes a bond and bond is in this way, there's still left one odd electron, free radical is there, and this free radical will be again supplied with HBr, where in HBr you are getting H dot and Br dot. One H dot will come here. So from here you will get one H dot, and these two H dot will come up to give you the final structure as, and bromine will come here. No matter, we need not to show this one. So your A is this and B is this. Very beautiful answer. You try to follow when there is HN. That will be free radical mechanism. It is true bromo 3-methyl butane. So what's happened? You are asked hydrolysis, and it will follow by SN1 mechanism. Question was asked in PMT, and it is again very important reaction, because there is again question of the shift of carbocation. So minutely follow the way we get. So whenever there is CH3 and CH3, there is a chances of going out of bromine. Though it is unstable 2-degree carbocation, let's see there is some possibility of rearrangement of carbocation to get the more stable carbocation. Let's see. So if it goes out, what we are getting? CH3, CH plus CH, CH3, CH3. Am I right? So you are getting this one. So instantly the next part is what? Hydrolysis, means acid hydrolysis. You need to treat it with water with acid, means OH and H plus will be get added. Am I right? So instantly you don't attack this to this negative to this one. You will get a big zero. So you see, are there any chances of rearrangement? Yes, there is. One things you give CH3, you do that hydrogen, bring this hydrogen here. The shift will be either this or this. Earlier I have written hydride shift will be more plausible. Hence there will be the sheet of hydride, not methyl, because if the sheet of methyl is there, again CH plus will be here. Again it is 2-degree carbocation. So that 2-degree carbocation will now transformed into CH3, CH2, CH3, CH3. Now instantly you see it is 3-degree carbocation. Now you are asked to acid hydrolysis. Am I right? You are making AH and H plus. Am I right? So this one instantly will react. Don't make to react with your OH. Acid hydrolysis means OH and H. So your final answer is. So don't be fast to write the answer. Please think over before giving the option 1, B, 2, C, D are correct. Am I right? Very simple. You see, methyl bromide cation. Methyl bromide cation, answer will be methyl cyanide. It is very simple. And on acid hydrolysis, and in the earlier classes I have told you, cyanide on acid hydrolysis become C double bond OH, carboxylic acid. This part is simple. CN on acid hydrolysis become carboxylic acid. It is known to you all. But next part, lithium aluminum hydride. There is 4 hydrogen. Am I right? 2H2, 4 hydrogen. So this is reduction. That part is it is B. That part is lithium aluminum hydride. It is not simple. It is a bit hard and need to some technique. We'll add hydrogen. One is in reduction, I have told in the previous class. One carbon, oxygen and carbon. One is carbon and other is oxygen. So we'll add up one hydrogen here and one hydrogen here. Am I right? And next, when there is lithium aluminum hydride, there is 4 hydrogen. Am I right? We need another hydrogen. So this is one hydrogen and this is one hydrogen. I have given dot 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 because there is a question of balance. We will not think about this. We will think of the correct answer. I will get. So here you will get loss of water. This is strict, not mechanism. So you are getting CH3, CH2OH. You may not imagine the result. So carboxylic acid on reductions, you are getting CH3, CH2OH. Some of you who may not be satisfied with this technique, you may do one things. Say CH2OH on oxidation, be very often I tell this further oxidation become carboxylic acid. Am I right? So your starting material is CH3. Am I right? There, but reduction is the reverse. COOH becomes CHO, CHO become CH2OH. Am I right? So those who cannot understand this, so you see when you have got carboxylic acid COOH, COOH, COOH. Am I right? So in this place you keep CH3 fixed, and in place of COOH you write CH2OH, because COOH on reduction you will get alcohol CH2OH. You apply the trick also, and those whenever you will get the structure in this way, CH2X here, chlorine, bromine or iodine, mind that you instantly remove this one, then you will get what? Benzyl chloride, benzyl bromide, benzyl iodide. Mind that this, you are getting this. So this is a carbocation, this is a carbocation of 1 degree. You may tell how 1 degree may be proceed to SN1, how answer is SN1 mechanism. Answer is very simple. If it is aromatic, so then this 1 degree carbocation very often rearrange in this way occurs. So you will get the structure in this way. I am not writing the details of this one. Again, this will come forward to this here, means resonance stabilizations occurs. So that's why this all give you CH2Cl, CH2Cl. When it removes out, it will benzyl halide, and this benzyl halide is a resonance hybridide. Still, it is 1 degree alcohol carbocation. It will give you a carbocation. So it is more stable carbocation. Answer was question was asked in CAT SN1 mechanism. Which one will show? It will SN2, because 1 degree. This is CH2Br 1 degree. This is PHTCOCl. It cannot break. Am I right? All are 2 degree. So come to this one. You are getting Me means CH3, C, CH3, CH3, C, H2, Br. So fact lies here. How can it be SN1? Very often I told you a bit earlier, you see, make carbocation, see whether there is any shift to make the stable carbocation. So you just try to make carbocation. So what you are getting here is CCH3, CH3, CH2 carbocation. It is 1 degree carbocation. It is 1 degree carbocation. So again, in nucleophile attacks, it is SN2. From backside, this side, that side, because 1 degree carbocation, 2 degree carbocation very often proceeds through the path of SN2 mechanism. So see, there is the shift of methyl shift. Methyl 1 to methyl shift. 1 to methyl shift. So what you are getting here is CH3, CH2, and CH3 group has gone here. So what you are getting is 3 degree carbocation. Now nucleophile attack with 3 degree carbocation is more stable carbocation, is SN1. So it is a bit tricky question. So this will show you SN1 mechanism. CH2H, CH3 whole thing to CHX, CH3 double bond CH, CH2H, PH, CH2X, order of SN1 reactivity. Which one go faster? You are asked to make the order. Just you see, this is 1 degree. If you want to remove X, this is 2 degree. Sorry, 1 degree carbocation, it will follow SN2 mechanism. Again, if you remove H, this is 2 degree carbocation. 1 degree, 2 degree carbocation will follow. No, you are asked the order of this. So certainly this is SN2, and if you make it this, maybe SN1. So order of SN1 reactivity, Benares Hindu University question was asked. There is no structure here. There may be some shift. It is a bit 2 methyl group is there also. Plus I effect is there. It is more stable, and it is again more stable because there is shift of double bond, and here there is phenyl. A bit earlier I have told you, when you get this benzyl halide, so if you remove, then you will get carbocation. This carbocation is resonance stabilized, so it is highest, second highest, least. The order of SN1 reactivity is this. It is least SN2, no chance. Now this question is again very important. CC, am I right? Again, uh, you draw the structure of this one, then you can understand the fact. So you write H, here C6, and no hydrogen was there. So this is methyl. So the highest possibility SN1 mechanism lies with this, because here two phenyl group is there, along with, if B is removed only in this molecule, the stability is huge, because the resonance stability with this benzene and this benzene occurs, and here methyl group, no hydrogen is there. So best possibility of SN1 is with this. Your answer is this. Here it is one hydrogen, here is two hydrogen, there is no hydrogen. It is best. Just you see the hydrogen and number of phenyl group. More the phenyl group, more is the stability for reaction towards SN1. But here also two methyl group, but there is one H, there is no H, so it is most stable. Methyl formamide. So protic solvent. You know the reagent first, then we will talk. That question was asked in AIEEE, so it is a very important question. A bit earlier I told you that iodine is the best leaving group, so we should have left iodine. But here the main peculiarity of this reaction, iodine will remain in the same position. So what you are getting here is, this is iodine and this is CH2Cl, and we are making to react with sodium chloride, dimethyl formamide. It is the best solvent. It is polar and it is protic solvent. Dimethyl formamide is a polar protic solvent. When there is a polarity, so this is plus and minus, so instant chance is to form sodium chloride. There is Cn, it is ionic. So if your solvent is methyl formamide, is a polar protic solvent, so polar protic solvent has the more speciality is that it will form ionic compound, and which ionic compound will immediately precipitates out in the protic solvent DMF. So the reaction proceeds in this way. This is the option is correct, because NaCl form will be precipitated out and the product will CN will here attack, because if it removes, it is carbocation and this will again stabilized and cyanide will attack as nucleophile. There is no question of leaving this one. This is only because where ionic compound form is precipitated out in the DMF solvent. Then class, in the next class I will start with chloroform and iodoform, and in one slot I will complete this structure.